Hi guys. So what do you think happens if you're a NASA designer, engineer, and you're charged with building part of a spacecraft, but you use units that are the US or the English units for parts of the spacecraft, and then you partner with some people in Europe, and they're using the metric system for their design, and they design their parts over there in the metric system, and then you bring it all together and build your spacecraft. What do you think might happen? Well, it's probably a lot of wasted money because the parts aren't going to fit correctly, or it's not going to do what it should have done. And you're going to have a lot of scientists doing Homer's facepalm smack because it was a simple error that they could have fixed. So this actually happened very recently, actually, in 1999. It was called the Mars Climate Orbiter, and all of a sudden it took off, went off great, and then a few months later it disappeared. They couldn't track it anymore. They didn't know where it went. And what they realized is it probably crashed into Mars because of certain control aspects that were designed in the US were done in US units, and the rest of the world doesn't use US units. They use the metric system. So as scientists, we're going to use what the rest of the world has agreed upon and uses to communicate, so we don't have errors like this. So we're going to use the metric system in our class. We're not going to use the US system of feet and pounds and Fahrenheit for those different measurements. Okay. So some common metric prefixes used in chemistry. These are not all the metric prefixes. These are just the ones that I want you to be aware of. So looking here, there's 1, 2, 3, 4, 5, 6 that you need to be paying attention to and know cold. So take a look. You got mega, kilo, centi, milli, and then nano after micro. Sorry. So we have some symbols here. We have factor and we have scale. Pay attention real quick to the part here that says base, right? So this is where kind of our starting point when we're talking about a measurement. Maybe it's distance or length, and we're going to use meters. Maybe it's volume, and we're going to use liters, or mass for grams. And therefore, there are two prefixes or two metric units that are above the base, so larger than the base, and then there are 4 smaller ones. Well, why does that kind of make sense? We're studying small stuff in chemistry, right? We're studying very tiny atoms, so we're going to deal with more of the smaller prefixes. Though a lot of times we need a lot of this stuff to see it, so sometimes we'll come across the kilo or the mega. So make sure you know this information cold. The factor information tells you you know, kind of the scale, how large this is 1 million times the base for mega. For kilo, it's 1,000 times larger than the base, and so forth. So make sure you know those guys. Base units, I just talked about a couple of them. So if we're going to measure distance, we're going to do that in meters. The symbol for meters is m, lowercase m. Be really careful with the symbols, by the way. For the symbols for milli, you are going to say, all right, I thought we just said m was for meter. Well, yeah, milli also has a lowercase m, and then there's a capital M for mega. So be really careful. Pay attention to this, whether it's capital or lowercase, and whether they're talking about the base or one of the prefixes. Then we have liter, which is a capital L. A lot of times you'll see it as lowercase l. It's supposed to be capital. G for gram. We should know these forward and backward. We've dealt with them since last year, I'm sure. And then we also got time. And I've separated these two because this really is not part of the metrics. It's more of the scientific international system, the SI, sometimes you'll see in your textbook. So we'll just say whenever we're measuring time, we're going to use seconds, lowercase s for the symbol, and then temperature is going to be in Celsius. We're also going to talk about another temperature unit this year called Kelvin that we'll talk about more once we get to that part. So we just talked or saw a video on scientific notation in video or level 1. So reiterating some of that information with these metric prefixes. Here you go again. Make sure you know the scale and the factors and the symbols for all of these guys. Notice nano, where we have negative exponents, right, for very small things. So again, -9 for nano, -6 for micro. And we were going in these steps of 1,000 changes of 1,000 for milli, micro, and nano. Same on the larger end up here for kilo and mega. All right, so let's talk about some conversions really quick. Really, you should be able to go backward and forward with any of these if you know the scales right? It shouldn't be too difficult to be able to go, change something in megameters to kilometers and so forth. So there are a few though that will come up more often than not in chemistry. So you got to know these following ones down pat. You got to know them cold. Okay. So what if you want to go from kilograms to grams? Why would you do this? Well, a lot of times we need a kilogram or more of a substance to make a solution, for example, and or maybe you want to make less. So we have kilograms and grams we go back and forth with quite often. So you got to know that 1 kilogram is equivalent to 1,000 grams. It's not the opposite, and that's where people make most mistakes. So let's say 1,000 kilograms in 1 gram. Okay, so let's say, for example, we have 34.54 kilograms. How many grams is that? Well, you would set that problem up like this: 34.54 kilograms. We're going to use our dimensional analysis, our domino method. So kilograms should cancel, and then we're left with grams on top. So it's 34.54 times 1,000 divided by 1, and we get 34,540 grams. It's as simple as that. Okay. Grams to kilograms, so the vice versa, the opposite. It's a very similar problem. Let's say we have 0.0345 grams. This time our domino is flipped over where we have kilograms now on top. We have 1,000 grams on the bottom of our domino, and we get a much smaller value this time, and that makes sense because kilograms are smaller than grams. Nanometer to meter. Very, very tiny scale for distance, or we'll talk about the radius of atoms this year. So we need to be able to talk about how big are atoms, and nanometers are a way we can communicate that. Meters are much bigger. So we need to know that there are 1 times 10 to the 9th nanometers in 1 meter. So what if we had something on the scale of 103 nanometers? How many meters would that be? Here's our dimensional analysis. Nanometers are going to cancel. We're left with meters, and we get 1 times 10 to the minus 7th meters. Again, the math when you're doing this, guys, you just multiply across the top. So it's 103 times 1, and then divide by whatever our denominator here is in our domino on the bottom. Meter to nanometer, so the opposite. Very similar setup. This time we're canceling meters to be left with nanometers, and we get 1.2 times 10 to the 3rd nanometers. Milliliter to liter, this is a very common one that's done all the time. You should know this one absolutely, especially when you're measuring small volumes in our class. We'll almost always do it in milliliters, which is spelled incorrectly there, but just trust me, we're talking about milliliters. So we have 1,000 milliliters is equal to 1 liter. Make sure you know that, guys. That's something you just got to maybe commit to memory. 11.4 milliliters, then how many liters is that? Well, you should already be thinking, all right, milli is smaller than liter, so it's going to be a small number, right? It's going to be smaller than 11.4. All right, so here's how we set it up. We have 11.4 times 1 liter divided by 1,000 milliliters, and we get 1.14 times 10 to the minus 2. So yeah, we're smaller than our original milliliter value because we went to a bigger unit. What if we're going the other way? 1 liter is equal to 1,000 milliliters still. So if we had 2.5 liters, how many milliliters? Think about that for a second. Think, okay, what's bigger, liter or milliliter? All right, liter is a bigger unit, so I should have lots of milliliters in these 2.5 liters. And that's exactly what we get. We get 2.5 times 10 to the 3rd. So many more milliliters in 2.5 liters. All right, finally, the most kind of complicated one. You'll often see volumes in cc's or cubic centimeters, especially if you do anything in the medical field. cc's are used all the time. You know, give them 10 cc stat. You'll see it on the medical TV shows, right? I don't know what they're giving them, but it's stat. So we need to know that a cubic centimeter is equal to or equivalent to 1 milliliter. So that was going to help us get from cc's, which is it's not the metric system, into something that is the metric system, milliliter, and do some conversions from there. So 1 c or 1 cubic centimeter is 1 ml. That's what we got right here. We have 1,000 mils still equal to 1 liter. We know that. So how many liters are in 24 centimeters cubed, or 24 cc's? Well, let's deal with the cc's first. We're going to convert that. It's 1 to 1, right? So 24 cubic centimeters is the same as 24 mils. And then we're going to convert the milliliters. This should be 1,000. Let's put an extra 0 in there. Thousand. So we then times this by 1, divide by 1,000, and we get 2.4 times 10 to the minus 2 liters. So a smaller value because we're in a bigger unit. If we go the other way, if we say, all right, we have 0.5 liters. How many cc's or cubic centimeters is that? Same sort of equivalence, same information that we talked about in the first problem. So here we have 0.5 liters. We'll deal with them first. Cancel liters, get to mils, and then we will convert our mils to centimeters cubed, which is just by multiplying by 1, and we get 5.0 times 10 to the second centimeters cubed, or 500 cc's. So what should you have learned? You should have learned that we're going to be using the metric system. It's very important in science. If we want to communicate with the rest of the world, we really should all be using the same sort of measurement system. Make sure you know the names, the symbols, and the scales for the comic metric units. There were 6 that were outlined in the notes here. Those are the ones that we're going to use in chemistry. And then make sure you feel comfortable converting between the metric units, including cubed volumes.